We're going to be making a demo game thing today. And I started working on this in the last class, and I talked a little bit about what the game is going to be, but I'll talk about it here. So I'm creating this text-based Pokedex game. You don't have your own Pokemon, but there's 4 different kinds of Pokemon you can encounter in the world, and you'll catch. The objective is to catch them all, basically. I'm not putting in an actual terminating condition for the game because like this is just supposed to be a demo. It's not supposed to be like a full-fledged game. A lot of this is just just demonstrate certain concepts. So some of this will be for your game. You'll have to go a little bit deeper than what I am doing here. This is really just bare bones what I'm creating here. So I created this stuff in the last class. Um, some of you might ask about the ATM lab. I did that in the previous class, and I will be posting this code online. I'm not going to go over the code in this class because I spent the entirety of the previous class going over this. So if you guys want to follow through with how I built this and me explaining the decision process behind this ATM program and what I did, I encourage you to go check out that class. And I just live code it all and I walk through everything. So that being said, let's get over here to our game. So I've created a basic map and I've created nodes to go in that map. So basically how the game's going to work is we have a 4x4 map right here. It's a 4x4 map and the user starts at 0, 0. And walking onto each node, there's a chance that you encounter a Pokemon. It's a random chance. And whenever actually one thing before I forget, I'll take care of that later. But basically, anytime you step onto a map and there is a Pokemon there, or you step on a node, and then we're going to check if there's a Pokemon. Each Pokemon has a certain, or each node has a certain chance of a Pokemon showing up. And yeah. Set. Set Pokemon. I gotta do this, and then this dot local Pokemon is equal to local Pokemon. Okay. I'll come back to the map. See. Boolean has Pokemon is equal to that. And then if as, actually we could just do. So basically every time we are stepping, we're gonna update gonna check if there's a Pokemon encounter. So if there's a Pokemon encounter here, then we're going to, at that node, set local Pokemon, and it's going to be Java util random new random next int 4. So it's going to generate a new integer between 0 and 3, which is the valid indices in our Pokemon's array. Yeah, that will be the Pokemon that's in that node. Return true. Else return false. And we don't do any of that. So basically, anytime we step into a node, we're going to check for a chance. Each node has like some random chance of encountering a Pokemon there. And I created that at, if you go to the node, there's a double chance, and that chance is equal to math.random. Math.random creates a number between 0 and 0.99. So there's anywhere between a 0 to 99% chance that there's a Pokemon there. So whenever we're walking around, we check to see, hey, is there a Pokemon here? It's just done through random number generators and etc. etc. Then we'll log them in our Pokedex as we encounter them. And I think that's all that's really left here is to kind of create the main driver in the combat encounter. We'll call this encounter.java public class encounter. And there's a few things when we create an encounter. Public encounter. We want to know private node counter. We want to know the node that we stepped in. Or actually, private int x and y. We want to know what the user's x and y are. Int x, int y. So this dot x is x, this dot y equals y. So we have all that. We also want to access the map object, private map object. This dot map object equals map object. And then any more I'll kind of fill in as we need. I think this is all we need for right now, but there's probably going to be other stuff that I need. So basically, what's happened up to this point, well, when this gets called, what will have happened is we will step into a node. There's a Pokemon on that node. If there's a Pokemon on that node, then we need to launch the encounter handler, and this is what what runs it. Public void run. So in our encounter, we're going to basically offer the user a few options. The user will get to, oh, we should also pass in the scanner object. So the user will have an option to basically try to catch the Pokemon or run. And the way it'll work is the user will go, they're going to try to catch the Pokemon or run. If they run, we're just going to let them run. We're going to end the encounter. He's not going to have caught a Pokemon. But if the user tries to catch it, then we roll a dice and see, based off the Pokemon's chance to be caught, we get to see if he gets caught. If the Pokemon gets caught, great. Combat it. The encounter ends, and we move on with the exploration loop. If it doesn't, then if it doesn't end, then we're going to give the Pokemon a turn, and the Pokemon will have the chance to run away. That's the one thing it's going to do. It's just going to try to run away. And we're going to roll dice for that. If the Pokemon runs away, combat ends. And then we go back to the beginning, right? So int round equals 0. While true, we'll just do an infinite loop for now. If round modulo 2 equals 0, if the round is even, it's the player's turn. Let's call it user's turn. Otherwise, it's the Pokemon's turn. System println, what would you like to do? And we'll have the options of println 1 throw Pokeball, or 2 run away. And we're going to call a switch statement on sc.next int. Case 1, case 2, default. And just to be consistent with what I was doing in the bank app, and just so I get to demonstrate try catch loops to you guys as well, I'm going to do a try catch loop or a try catch block here. So before I go further, who remembers what a try catch block is and does? Who can tell me what try catch blocks do? What are they for? Anybody at all? You can unmute yourself and talk to. Yeah, you check for errors. You try to run a block of code, and you're going to be listening for errors. That's what the catches are for. Now, something to know with the errors, there is a general just exception class in Java that encapsulates all kinds of errors. The problem with just using only exception is that you don't know what specific error it is. All you can really say is, hey, something went wrong, sorry. But then there are certain exceptions, like for instance, one error that could happen here, we're asking the user for an integer. What's something that could go wrong in this switch statement, right? We ask the user for an integer. What's something that could happen? We ask the user for input. We're expecting an integer. What is a very common error we can get here? You don't have to know the specific error, but just like what is the error case? Like what happens to cause the error? That would be very common here. Any thoughts? Anyone? We ask the user for input, and we are expecting an integer, right? What's something that could go wrong? What's something that could throw a runtime error? Because the whole point of try-catch blocks is to handle runtime errors. Runtime errors are things that could happen, are errors that'll occur when the code is running. Normally, a runtime error will cause the program to just crash and stop executing, or just make your program fail in some way. But that's try-catch blocks allow us to do something about if we encounter a certain runtime error. So in going back to the question, we ask the user for input. We're expecting an integer. What is something that could happen here that could cause a runtime error?
Like an infinite loop?
No, not quite. Because we've already got an infinite loop. That's by design. I'm just saying, like, don't think about just like this specific part. Exactly. Ali has it right. If the input isn't an integer, that's going to cause an error. It's going to cause a runtime error. If you guys remember, if you ever fiddled around with your code, you'll get an error that says input mismatch exception. And you don't have to memorize these. I just kind of know them because these are like just really common ones that happen and you see it all the time. But Java errors. If you go and you read the documentation on all the different error types, Java exceptions, actually, I should say. So if you go to tutorials point, for instance, it should somewhere have throwable exceptions, runtime exceptions. Yeah, it should somewhere have like a list of all the different types of list of all Java runtime exceptions. Yeah, so here they have a whole list of the different exceptions that you could have. You could just read this and think about what are the different errors we can have in any given point. So here, one common one is input mismatch exception, and I'm just going to remember this is the type. This is the type. This is the class, and then we're just going to give it a reference name here. I'm just going to call it E, or you can call it error. And then you can usually just have it be like something like and here we'll have a customized message here, system error, println. The reason for the system error is when we trigger this, you get a apparently prints in red. So system error println will say, please input a number. And we'll also have a more, and remember, these work like if statements, so it'll check this one first. And so let's say there's just a general exception, right? We'll say system or Java print error. E to string e dot print stack trace. That's the one. E dot print stack trace, and we'll put out a system error and something went wrong. I'll make it in all caps just to be obvious. Okay, so what's going to happen here? We're going to try this, meaning we're going to try to execute system.nextInt or scanner.nextInt, and if we encounter a runtime error, then we're going to start running through this list to see what the runtime error is. So let's say we get a input mismatch exception error, and then it'll come here and be like, oh, cool, we caught this. So we're going to run this thing here. And actually, I'm going to put this in while. I'm going to put this in its own while loop. So that, you know, if something goes wrong, the user can try to input again, and it's not just going to keep going on with the game and skipping their turn. And what I'll do is in all these breaks, input. I just realized something. This break breaks out of the switch statement. Boolean repeat is true. And here at the end, we'll say repeat equals false. Repeat equals false. So on. Not a valid option. Please try again. So here we go. So if they throw a Pokeball, we're going to run some kind of here. I should also pass the Pokedex actually. Copy this over here. That's this dot this is equal to that. And the Pokedex, I'm going to make a function called public Boolean attempt to catch. We need to give it a Pokemon. Do I have a get chance over here? Pretty sure I do. Yeah, cool. If Pokemon.getChance is math.random is less than or equal to the Pokemon get chance of, like, let's say they have like a 65% chance of being caught. If this random number generator generates 6.65 or less, then yeah. Oh, sure. I can explain try catch again. Where did we have that? Was it in the encounter? Okay. So when Java sees a try block, it's going to say, okay, for all this code in here, I'm going to execute it until I encounter a runtime, until I encounter some kind of thrown error. That could be a runtime error. It could be some other thrown error. It doesn't matter. But it's going to keep running this block into this bit of code until it encounters an error. So we're going to run all this until it encounters some kind of error. If it encounters an error, it's going to stop where it is, because normally what would happen if we didn't have the try catch block, normally the program would just stop running. It would, we'd get the runtime error and the program would crash. or just something would eventually cause it to crash. Then it's going to pop out of here and say, okay, we've caught an error, and I want to compare that error that I've caught because each error has a type to identify what that error is. I'm going to compare that type with each of these possible exceptions. Um, like for instance, let's say we were like doing division problems and the denominator of the division was a dynamic variable. It wasn't controlled. We don't have a way of knowing if this denominator is less than zero, is equal to zero. If the denominator is ever equal to zero, and like we try to divide by zero, the program crashes with the error of arithmetic. It's going to give some kind of like, there was a math error. There's an arithmetic error somewhere. So maybe to catch the event that the denominator is zero, we could put a catch statement to catch that specific case. These catches are basically like just almost like if-else statements. We're saying, okay, if we catch this kind of error, if this kind of error occurs, then we're going to do this. If we catch this kind of error, and in this case, this is a very generic error. If there's a generic error, we're going to just tell the user, yo, something went wrong, and we're going to print out the stack trace, meaning it's going to give us the roadmap to where the break happened, like all the stuff that was called to where the break happened. That's specific to this implementation. Notice that I didn't include the stack trace here because I don't care about that because I know what the error is. It doesn't matter where the break happened. We're just telling the user, yo, you didn't give us a number if this specific error happens. That's basically what try catch is. Try catch is just error handling. So you might have in the past been doing what we called error handling in the past was actually sanity checks. Rather than actually catching an error that like caused the program to break, we were instead using if-else blocks to make sure that the input we were getting, the data we were working with, is what we expected it to be, is what we were hoping it to be. Does that kind of answer your question a bit, Ali? Okay, cool. So where were we? Back, we did encounter. Oh, Pokedex, we're trying to catch it. So, Pokemon that get a chance. If we do catch it, then we're just gonna go ahead and where's that method? Add entry, the Pokemon that we just caught. Otherwise, turn false. Turn true, and actually, this is just like just a little thing for me, but I have the if condition here, and then if that if condition isn't met, then we just return false. So we didn't catch the Pokemon. So over here, if we throw the Pokeball, we say Pokedex try attempt to catch. Attempt to catch, and then from the map object, we want to map object dot I'm gonna have a get current Pokemon. Return map at yx, and if you're confused about why it's yx, I did a demo. I explained it in the last class, so definitely go watch that video. Definitely watch the whole of. I would say definitely watch the whole of like last lecture, both lectures this week. I would say watch both of them because these past 2 weeks, the demos I've been doing are just so big, and there's just been so much stuff to cover that I have to kind of just split the lecture asynchronously between 2 classes. But still try to put it in a way that makes sense. But this one is kind of going to require you guys to go back and forth. I guess I could draw it out real quickly. The reason why it's like that is if we think about a 2D array, right? We have some number of rows going down this way, some number of columns going this way. And if we, we have an array of R rows and C columns, right? This is specifically for a 2D array. And remember that an array is just an array of arrays. So the rows are actually just they're individual arrays that have that each contain an array of this many. So it can be represented, it can be used to represent a 2D board or a 3D grid, but like just realize that the strict definition of an array is of a multidimensional array is that it's an array of arrays. And you know, you might want to reference back to the multidimensional array lecture for that. But anyways, we have, you know, like some grid here. Like over here, we're at like 0 row, 0 column, first row, 0 column, second row, 0 column, etc. Up until the last one. And remember, what is the, who can tell me, what is the max index for any given dimension of the array? How do we always know what the max index is? There's a very easy way to know. You guys remember how we given an array with some size, how do we know with some size n? How do we know what the max index is going to be in that array? Does anyone remember? Alex, close. How do we start indexing? What number do we start counting from with indexes? So look at this. This is our first index. Right. So if we start at the 0th index and there's n, there's length, there's some given length, what's the max index going to be? Exactly, length minus 1. So this would be r minus 1, 0. This would be c minus, or 0, comma, c minus 1. And then down here is r minus 1, c minus 1, right? 1, c minus 1, 2, c minus 1, etc. So if we want to, let's say we're at some node, okay? We're at some node over here. If we want to go north, what dimensions do we change given row and column? If we want to go north, what do we change? How do we change row and column to go up 1? I'm not going on until people answer because this is really, really important that you know this. So I don't know if people are just like tuned out or what, but you guys should know this. I would hope that you guys know this, because if you don't, then we really have to go back. Is it column minus 1? Because look at, if we're going north, like look at where we're going, Alex. You're on the right track. Do we have to change the column to go up in the map? Exactly. Row minus 1. And then no change for the column. If we want to go east, how do we change the rows and columns? Yeah, column plus 1. And this is not changed. And obviously, you know, if we're going to go south, then it's just the opposite of this. Plus 1, 0. We're going to go this way. Minus, or 0, minus 1, right? And do you guys, so we've got this in terms of rows and columns. Do you guys buy that going north is moving in the y direction? And since when we're going up or down, we're modifying the rows, that this should be y and this should be x. Do you guys kind of buy that? Okay. I was disconnected, so maybe that's why you guys weren't responding. Can you guys hear me now? Hear me okay? Okay, cool. Anyways, yeah. So do you guys buy that because when we're going up and down, we modify the row is the y direction, and when we go left and right, we modify the column is the x direction? Do you guys kind of buy that? So that should hopefully make sense why we have the map like this. You could just as easily have named these R and C instead. I just named them X and Y just because. Just know that with multi-dimensional arrays, with two-dimensional arrays, instead of yx, it's going to be, or instead of xy, it would be yx. I know it's most of the time when we're thinking directions, we want to put x then y, but for these, it's the order matters here, so it has to be y then x. So at that map, turn map dot get current Pokemon. I think we have that. Get return Pokemon. Where was I just working on a second ago? Aha, here, it was under map. Okay. I'm gonna say check for Pokemon. Okay, cool. I'm gonna set the local Pokemon. We're gonna do it using Pokemon's at that. Okay, cool. Turn. Awesome. Okay, back to the encounter then. So attempt to catch. Object get current Pokemon at X and Y. Yeah. And the map should also have ways to get. Should make these public to make it easier because I don't want to write more getters and setters. So because of that, we actually don't need the users. Actually, wait, no, we don't have to get that from the map. Never mind. We'll keep those private. And then over here, actually we do. Never mind. This public. And we won't have X and Y, but what we will do is we'll say X equals map object dot user X, Y equals map object dot user Y. And that's how we'll know the user's X and Y directions when we're in here. Okay, so back to here. We run away. Okay, so we attempt to catch the Pokemon. Pokedex, attempt to catch. Turn true. I'll say if all that. If we manage to catch the Pokemon, system until end, you caught the Pokemon. System until end, you encounter. Just want to double check the description for these. Yeah, they all have a something. You encounter map object dot get current Pokemon at X and Y, and then get description. And I need to write that getter over here. Public string get description. Oh, I made the description public. Awesome, cool. Let's go back to encounter. So you encounter this Pokemon. Then we start all this up. What would you like to do? Throw a Pokeball, run away, yada, yada, yada. If we catch it, else. So in this case, we say repeat equals false, else system println. Okay. I'll break this. And that puts us at the beginning of the loop. Okay. 2. System. Println. You run away. We'll just let the user run away. So whenever the user gives us a valid input, we basically are done with this while loop. And then we say round plus plus. The user's turn is ended, and then we're the Pokemon's turn. And then we're just going to have the Pokemon try to run away. Map object get current. Dot Pokemon public Boolean try to run. Attempt to run. Turn. Random is less than or equal to chance. So Pokemon that have a high chance of being caught also have a high chance of running away. That's how we've decided to make our system. Import Java lang math. So let's say system the Pokemon tries to run, and then if attempt to run So if he does manage to run, then we say system at println the Pokemon escaped, else println you caught up. Cool. And then it'll be the player's turn again, and then they'll try to catch it. And this is just going to keep going until we either catch the Pokemon or it runs away. Right? Cool. So one thing that has to happen here, one of the things I want to do in my game is if I've already encountered a Pokemon before, my Pokedex will know. So it should tell me the name of that Pokemon rather than tell me that I encountered something of a description. So what it's going to do instead is if Pokedex dot check if encountered before, and then the Pokemon is the that. So if we've encountered it before, then we're going to say similar to this, except we're going to say get name. If we haven't encountered it before, you encounter a Pikachu or Geodude or whatever. And then if we haven't seen it before, then it's going to give us a description of what we see. That should basically be it, actually. I thought I had way more to do on this, but we might be pretty close to done. Now comes the error handle. Oh, wait, I haven't linked any of this up. Duh. I just finished the encounter. I haven't gotten the main driver done. Okay. At this point, I've created all of the pieces, all of the tools, all of the pieces that I will need. Now it's just a matter of putting them all together, right? And this is kind of where someone was asking in the forums, how do I get started with milestone 3? Right now, this is kind of where you should be at. Pretend that these are all separate files, right? In one way or another, where you leave off after milestone 1 and 2 is that you have all of your pieces ready for the game. Now it's just a matter of putting it all together, is linking everything up. So, and the reason I'm doing this, so what I'm doing here is I'm creating a self instance of the main method, and I'm just calling self.run. I could even just do this new main.run. And the reason I do that is so I don't have to have a public static for every method that I call. This is just how I prefer to do it. There's no real rhyme or reason. It's basically literally just to avoid having to write static over and over and over in the main method, at least. So I'll just say system and println welcome to the Pokedex Safari. I don't know. I'll just name it something. And then map object equals new map. And when we run the map object, it should create the nodes and the Pokemon that it needs. And each node that you create has a chance to create a chance, then it initializes the local Pokemon to null. And check for Pokemon. If there is a Pokemon, then we set a local Pokemon to be one of the random ones here. Cool. New map object. So while true, and I'll just put a comment here that this is the main game loop. While true, we're going to say we're going to say system out println what direction would you like to go in? System print valid moves. Say map. Get valid moves. Actually, instead of doing that, we're just going to say void system out print main.java map object get valid moves. Cool. So that's going to print out all the valid moves we can do from our current location. And we're going to say while repeats equals true. So while we're repeating, switch, I'm going to say try switch SC dot next line to uppercase. Or actually, instead of doing a switch, we'll say actually, no, switch will be fine. Case. Make sure I don't have a. Say false. And the reason I'm doing it this way, you guys will see here in a second, is because I just kind of want to make it easier for my try catch. So I'm going to say so try while shit, hold on one second, sorry. Move user file move user sc dot next line. Cool. So while all that is happening, so long as this thing returns true, meaning it only returns true if we and in the default, meaning they did not give us a valid direction, we're going to keep repeating. Wow. And we'll actually keep the loop body empty because there's nothing we really want to do in the body. Because we have like everything we want to do in the body in the header, we can actually leave the body empty. And I think we can, I know you can do this in C. I wonder if we can do it in Java. You can just put a semicolon there. Basically what this is saying is we're going to run this. We're going to get the user input. Then we're going to try to move. Then we're going to look at the input that we get back. or we're going to get the response if it's a false or true. If it's false, we're not going to repeat this anymore, meaning we're going to stop updating the direction, meaning we're going to stop asking the user for what direction to go. And we're going to go on to the next line. And then over here, catch input mismatch exception. And I should copy that or from one of these other classes that have it. There we go. Also, one thing I forgot, I need a scanner object. I really hope I don't have a new scanner. Nope, good, okay. New scanner, nope. New scanner, okay. I'm just making sure I don't declare a new scanner anywhere else. Good, okay, cool. System len valid inputs. I should call this input error until line. It's gonna look really weird, but should work. Continue. Try block is gonna be empty. Do nothing. All right, actually, here's what we'll do. We'll say Boolean repeat equals that's while repeat try. Actually, oops, sorry. This should be equals true. I'm gonna see. Next line, catch input mismatch exception E, system error println, bad input, try again, and then catch exception, very general exception E, system error println, something went wrong. And printing the stack trace means you're going to get that the call stack, so you can try to pinpoint where that break happened. Okay, we're going to move the user. So if the once on repeat becomes false, meaning we're done sanitizing our user's inputs, we're going to check. Let's see if, where is it? Check for Pokemon. If there is a Pokemon, if map check for Pokemon, right? Cool. Yeah, if map.check for Pokemon. If there's a Pokemon encounter, then we're going to launch a new encounter. I'm going to say new encounter. And we need the map, scanner, and the Pokedex. Map, scanner, Pokedex. We should actually create a Pokedex object here too. Say Pokedex. dot run. So we'll create that new encounter and then we'll run it. And it will go through all of this and I'll run the actual encounter and then be done. And then we go back into our infinite loop. And actually, I don't need that there. Cool. Very cool. That should be our whole game. Let's run it now and fix out the bugs. Okay. Encounter 6. Cannot find symbol. Oh. Import Java util scanner. Pokemon.java. Okay, Pokedex at 16. Import Java Lang Math. Pokemon Java 14. Get chance. Wait, what? Where is that? Pokedex at 16. Cannot find symbol. Line 6. If. What do you mean? We call it right here. What? Oh my god. Okay, that's why. And then node at 8. Turn. Oh wait, no. That's not even right. We just don't have that. We just say math because this is part of the Java base language. Okay. Okay, now it should work. Now I should recognize those symbols. Pokedex at 18. If. What are you talking about, dude? I passed this as a. Oh, that's fine. Get chance. Then main Java 10 cannot find symbol scanner. So scanner. Location main line 32. main Java 32 variable map. Oh. Map object. Fix that, fix that. Okay. Should fix all those dumb bugs now. Now for the actual bugs, runtime bugs. Oh. Node in Java web user equals map object dot move user. So just before we go further, as long as you submit code that just runs, you're on a good path at the stage that you guys are at. So totally okay at this point. So we'll go east. Null pointer exception. Fun. Okay. Check for Pokemon. Map.check for Pokemon. Okay, that's where it starts. Line 20. Check if Pokemon. That should go into a node. I'm going to put some print statements here to see where the break's happening. Println a. And obviously, if I was using IntelliJ, I'd be using the debugger tool here, but I'm not using it. So we're doing old school print statement debugging. Okay, so breaks after A. Let's try to print out print f user y, user x, map y x. User y, user x, and then system out println map it user y, user x. Because those should be starting at 0, 0. So let's run this. East. Oh, I see. Now I know what. For int I equals 0 is less than map dot. Actually, say r equals 0. R is less than map dot length. R plus plus. For int c equals 0. C is less than map inner length. Map at rc equals new. Okay, cool. exception and thread mainline. Pointer exception. Add Pokedex. Check if encountered before. Okay, so let's go to the Pokedex line number 9. If I equals 0, return false. So if I is 0, it means we haven't encountered anything yet. Meaning all these are going to be null. Entry Pokemon encounter equals, yeah. So you encounter a large floating rock that seems to be just mouth and arms. Throw a Pokeball. Oh, let's go back to the encounter. If we catch the Pokeball, you caught the Pokemon, repeat equals false. Actually, if we catch the Pokemon, we just return. We just finish executing this because there's nowhere else, there's nothing else to do. And if we do that, we also return. Repeat equals false. And then we go on. Okay, cool. Fix the logic a little bit there. So what was happening is the combat with the Pokemon would keep going even after we caught it. So now let's go east. Let's go east again. Let's say 1. Throw Pokeball. Did not manage the Pokemon. The Pokemon tries to run. The Pokemon escaped. Okay. So now it's going to keep going after the Pokemon escapes. We just forgot to put in proper exit conditions for the encounter. So basically, when we return, meaning it means that this run method stops executing, meaning the combat is over. East. So you see a butterfly, I'm going to throw a Pokeball. We caught the Pokemon. Yay. Now we can go in a different direction. And we'll say not a valid. Get valid moves. Okay, there's also some like weird console stuff, but that's something I'll iron out way later date. But or like you guys can try to like fix it on your own, but it's just very, very minor stuff. It seems like east, south. We run away. I don't know why it keeps saying not a. That one keeps printing out sometimes, but that's weird. It's a weird bug that I really don't feel like combing through right now. But that's our game. We made a Pokedex game. And I know I kind of like in this class, because like the Pokedex game was like mostly done from the last class, I didn't say much, but we'll go through the code one time. We'll like trace through it together manually. So just to remember, just to refresh ourselves how the game works. We've created a 4x4 map that we're going to move through. In this map, we have a chance to encounter Pokemon that we want to try to catch. Whenever we encounter a Pokemon, we start up an actual encounter, like a combat encounter, if you will. And we only have 2 options in the combat encounter. We can either try to catch the Pokemon or try to run away. So we can throw a Pokeball to try to catch it, or we can run away. If we run away, we'll always succeed, and the combat will be over. We'll have just fled from the Pokemon, and the game will ask us which direction we want to move. Because it's an infinite loop of we're just going through this map we've created. Within the map, I have functions here to try and give the user proper directions that they can move in. There's logic that's checked here to see what the different valid moves are. After they've selected a valid move, maybe I do need break here. I just put a break just in case, because I think what was happening is at the end of this, it was like trying to come in here still. Sometimes switch statements are kind of funky. Anyways, we have a map of a bunch of node objects. You can think of like, you might even want to create nodes for your maps and have a node have an identifier of it's a hallway or it's a wall, or it's a hall or it's a room. Right. So we have a map of we have a 2D array map with a bunch of node objects within it. We keep within the map, we store our users' X and Y coordinates, which depending on whatever direction they want to go in, we update their coordinates. If there is an encounter that happens, we create an encounter and we pass over a bunch of the objects that the encounter needs to use. Our Pokedex, whenever we catch a Pokemon, our Pokedex will log it away so that if we encounter the same Pokemon again, it'll actually give the name this time around. And we'll run through the game one more time in hopes that we eventually run to we'll catch a Pokemon and we'll hopefully what package EM map Java 52. What the fuck? That's really weird. Okay. Whatever. Through some weird fuckery with the this thing keeps getting called for some reason, which is kind of annoying. Oh, then we should probably make a new line over here. We'll go east, throw the Pokeball, we caught it. Let's go west. And see, we encountered a Geodude again. And this time, instead of describing it, we encountered a Geodude because we've already seen this Pokemon before, so we know what it is. So yeah, the game is complete. That was the whole point of the game, is we would go around. We infinitely go around this map and we try to catch the Pokemon. And anytime we catch a Pokemon, it gets put into our Pokedex if we've not encountered it before. I will definitely put this code up, and I encourage you guys to watch the last class's video and play around a little bit with this on your own. Copy it over to your IntelliJ and just toy around with it. This is obviously a very bare bones version of like the game, and a lot of the systems that your game might need to have aren't in here. But there's also a lot of like the point of this was to kind of show you guys the idea of, hey, you've already got the encounter ready, right? Like this whole encounter object you guys have already built. This is your milestone 1. This is your combat. And then for this main, or the map rather, where I have like all the check the different directions that you can go in and all that. This is in your milestone 2. So your milestone 3 is really just putting everything together and creating like the interactable object effects and like adding a few extra things into your game to make it feel more alive. But your game is basically already done. The milestone 3 is really just putting everything together and making, polishing things up and doing a lot of testing. Any questions? I know I kind of like blew through today's stuff a lot. If there's anything like that's kind of sticking in you guys' head that like you don't quite understand, etc., let me know.
I have a question, but it's
Sure.
on fine. I'm kind of stuck in the in the main class where you ask the user to enter their PIN number, and once they enter their PIN number, I'll
Is this
try.
for the chapter 9, the chapter 10 lab or 9 lab or whatever it was, the ATM lab? I
Yeah.
went over that in the previous class. You should check out that last video. I mean, I can go through the program if you want. Sorry, go ahead and ask your question. I'm sorry.
Well, yeah. Well, I was trying. So once they enter their PIN number, I'm trying to get to display their name or like welcome username or whatever.
Okay.
But I'm not. I'm only since I'm only asking for the PIN number. Um, I'm kind of confused. How can I get that person's PIN, the person with the PIN number, that their credentials?
So I think you might have misunderstood the lab. What you were supposed to do was, and I took away this requirement because it was a silly requirement, but initially it asked you to ask the user if they want to log in using their full name or their account ID. Later on today, this morning, I changed it to be just your account ID, but that's okay if you want to go back and change your lab submission, just say that, you know, uh, based on your thing, I'm going back and changing it. But basically, you ask the user for their account ID, and then you ask them for their PIN. So their account ID is their username, their PIN is their password. Um, so once when you've got the user's account ID and password, then you can log them in, and you'll have some kind of variable like current customer, like whoever's the current logged in one. Like that's what I have thinking here. Yeah, I have a customer, current customer. So when a user logs in, I change this from being null to being an actual user.
Okay, I see. Okay, thank you.
Mm-hmm. Any other questions?
And this program is on iLearn.
I believe I put it up.
Oh,
Yes.
the
Oh no,
video.
I haven't put this up yet, but the video's up there.
Okay. Okay, thank you.
Any other questions? So next week will be kind of a session like last week. I'm just going to be answering questions and doing like just isolated code demos, just to help you guys understand concepts. So definitely come next week with questions for be it your CSC 210 final or just general. Hey, I don't understand this about Java or coding, but yeah, next week is just going to be an open session. And if you guys don't have questions, no one wants to ask anything, then we'll end early. Cool. All right, guys. Have a good weekend. Best of luck.